In this lecture, we are going to see the page replacement algorithm that is least recently used. Otherwise, we call it as an LRU. So, after completing this video, we are going to learn what is LRU page replacement and example of LRU page replacement and advantages of LRU page replacement and disadvantages of LRU page replacement. So, before we are getting inside the topic, that is what is the need of this page replacement is the paging is a memory management technique used in the operating system to manage the memory and allocate the memory to the process wherever it is needed. So it is a storage mechanism used to retrieve the process from the secondary storage into the main memory in the form of pages when the particular page is on requesting. So certain pages of the process are loaded initially into the primary memory. This allows us to get more process into the memory at the same time. Sometimes we will get the request from the many process for requesting the processor requesting for the page. But what happens when a process requests for more and more pages? Sometimes there is no enough memory is available in the primary storage. So we have to get that particular pages in the secondary memory for satisfying the current execution. There are three steps to deal this problem. So first one is we have to keep the process in the waiting queue until all other process finishes its execution. Thereby it will freeing the frames. And second thing is we have to remove some of other process completely from the memory and we will give free frames to the current process. And third thing is we have to find some pages that is not used always or not used right now. So move the pages to the disk to get the free frames. So this technique is called as a page replacement. This page replacement technique is most widely used technique. What is demand paging? The demand paging, the system loads the pages only which on demand. When the page is requested by any process or the page is on demand, that the particular page is not available in the primary memory, it will get the particular pages from the secondary memory. So we have to send the pages from primary memory to secondary memory is called a swap out, and we have to get the pages from secondary memory to primary memory is called as a swap in. Here page replacement. Page replacement is a process, a new page. A process requests a new page and supposes there are no free frames, then the operating system need to decide which page has to be replaced. The operating system must use any one of the page replacement algorithm in order to select this particular victim frame. So the operating system must write the victim frames to the disk and then read the desired page into the frame and that update the page tables. So page faults. The main objective of the page replacement algorithm is to decrease the maximum number of page fault. The page fault is basically it is a memory error and it occurs when the current programs is trying to access the memory for mapping into virtual address space, but it is unable to load into physical memory. That is referred as page fault. If the requested page is not available in the memory, that we call it as a page fault. In this lecture, we are going to deeply concentrating on this least recent used page replacement algorithm. This algorithm helps the operating system to search those pages that are not used over a short duration of time frame. So the page has not been used for a longest time frame, it has to be replaced with the newly arrived pages. So this algorithm is very easy to implement. Let us consider one example for this least recently used page replacement algorithm. Here consider the page reference string as 7 0 1 2 0 3 0 4 2 3 0 3 2 3. When we have this much of page reference string with the page frame size is 4. With this page frame size, we have to find the maximum number of page fault occur by using of this least recently used. So initially the page frame is the size 4, initially the page frame is empty. So the first 4 values are filled in the page frame. For example, the first value is 7 and it occupied the first frame of a specific first page of a specific frame, and the second location is occupied by 0, that is, a 0 is the second string and the third string is an 1. So the third position in the frame is occupied by 1, and next number is 2. The fourth string is 2. The string, the particular reference string 2 is occupied in the fourth position of this particular frame. So here there are no list of strings are available in the frame. So we are just mapping, we are just keeping all the 4 elements in that 4 frame position. So here that is, we call that as a miss rate. If actually the page, the string is already available in the frame, we call it as a hit ratio. The string is not available in the frame and we are keeping the string by using this least recently used algorithm, so that we call it as an hit rate. So in this next 5th step, the 5th string is 0. The 0, when we are checking the 4th frame, 0 is available, so we call it as an hit rate. Then we are checking with the next string, that is 3. We are checking here 3 is available in this frame or not. If 3 is not available, so we have checked the previous, that is least recently used. The least recently used number here is 0, 2 and 1. 0, 2 and 1 is least recently used here because it is used priorly. 0, 1 and 2. The next, the 7 is used the long ago. So the 7 is replaced, and in the place of 7, the 3 has to be keep according to the least replacement algorithm. So that is called as a miss ratio. Then the next string after 3, the next string is 0. 0 is already available in the frame, so we call it as an hit ratio. Again the next string is 4. We are checking this frame, and so far the 4 is not available in that frame, so we have to check the least recently used numbers. That is, 0 is least recently used, 3 is least recently used and 2 is least recently used. That 1, when compared to all these 3 strings, the 1 is used long ago. So in this place of this 1, we have to replace the 4. So now the frame is 2403 and the next number is 2. 2 is already available in this particular frame, so we call it as a hit ratio. Then the next number is 3. 3 is already available in the particular frame and we call it as 3 is a hit ratio. Next is 0. When we are taking this frame, 0 is already available, so we are not changing anything, so we call it as a hit ratio. Again the number is 3. 3 is already available in the frame, so we call it as a hit ratio. And 2. 2 is already available in the specific frame. The 2 is available at the top position of the frame, so it is also called as an hit ratio. Then the last string is 3. When we are checking this frame, 3 is already available, so that is called as a hit ratio. Okay. Here we have to calculate the number of miss ratios. Here the number of miss is 1, 2, 3, 4, 5, 6. So the miss ratio here is 6. So the total number of fault occurred here is 6. So likewise, by concluding that the least recently used, we have to check the previous strings. What are the strings we are used very recently, that strings we could not able to replace it. A string which is used a long ago, that string has to be replaced immediately. So this concept is called a least recently used page replacement algorithm. So the working of this least recently used algorithm is explained in this slide, that initially all the slots are empty. So we are 7, 0, 1, 2 are allocated to the empty slots. That is the first 4 steps. Then 0 is already there, so 0 page fault. So the next string is 0. 0 is already available, so we call it as an hit ratio. There is no page fault there. Then when 3 came, it will be take place of 7 because 7 is used long ago.